Number 10, our objective is, repeat after me, identify the difference, between insulator and conductor. In that objective, there are two words that I don't know. So I'm going to look at my anchor chart. A conductor, that's electricity easily goes through these objects. Objects like water, aluminum, copper wire. Think of a train conductor, all right? The person who drives the train. The other word I did not recognize was insulator. What's the word? Insulator. Think of an insulated lunchbox. So Mrs. Molesky's lunchbox is insulated, all right? So when you think of an insulator, think about my lunchbox. And that electricity does not pass through these objects. So it cannot go through a straw, a marble, plastic, or chalk. All right, and my ELL objective is students will be able to? Students will be able to define key terms. Define key terms. Related to insulators and conductors. Related to insulators and conductors. Okay, we're going to start off with a video like we do every science class. So it's Study Jams.
Whoa, the wind outside is freezing. Glad I've got my hat. I wouldn't be so sure about that. Looks like you got zapped. Oh yeah, it's my rock star look. Static electricity always makes my hair do this. Mine too. What's going on? It's electricity. You know, the energy that's caused by moving electrons. Oh, electrons are connected to electricity. I guess that does make sense. And you know that electrons are part of every atom. Yeah, they're like little moons zipping around the nucleus. Electrons have a negative charge, right? Yep, the opposite of protons that have a positive charge. Pro for positive. That's easy to remember. Hey, do opposites really attract? In this case, definitely yes. The electrons and protons pull towards each other. And the neutrons don't have any charge. Not the life of the party, huh? Not neutrons. But electrons are definitely partiers. They jump at the chance to visit another atom. So sometimes when objects touch or rub together, electrons hop from atoms in one object to the atoms in the other. And when they do, they cause little bursts of electricity. Hey, was that why I heard your hair make crackling sounds when you took off your hat? Exactly. Electrons rubbed off my hat onto my hair and gave my hair a negative charge. Static electricity. It happens when you rub a balloon against your sweater. Or your shoes rub on a carpet too. So that's what made your hair stand up? Yep, since like charges repel, all the negatively charged hairs pushed away from each other and poof. What about lightning? Is it caused by static electricity too? You bet. Clouds build up electrons in a negative charge until, zap, a giant burst of electricity flashes toward the ground. And static electricity is what makes socks stick together when you take them out of the dryer. I bet that means they have opposite charges, since opposites attract. Good thinking. When socks stick together, it's because one's got a positive charge and one's got a negative charge. Wow, electricity's amazing. And it's everywhere. It happens naturally in things like lightning, but we create it too. We build dams to turn water power into electricity. And wind turbines to turn wind energy into electricity. And even burn fuel to make energy from generators. And all that electricity lights our streets, houses and businesses, and stores. And runs machines everywhere. Incredible! All because tiny electrons move from atom to atom, giving off electricity. Who knew that just touching or rubbing things together could make electrons jump from one atom to another? Or that those electrons make negative charges build up and cause static electricity? Or that like charges repel and opposite charges attract? It's mind-blowing. Really, life without electricity would be positively primitive. Well, I could live without my static zapped hair, but I sure can live without this. Electricity rocks. Wait, girl.
Okay, so that was just a quick video on electricity. Can someone just give me an example? example of static electricity that you saw in the video. How could I get static electricity? Ariel?
With the lightning,
With lightning? All right, Justice?
when you go down a slide,
Okay, going down a slide, you could get static electricity. Last one,
when
Ryan.
you rub your stuff on the rug.
When you rub your socks on the ground. Okay, we're going to move on to the next part of the lesson. All right, so what is the difference between an insulator and a conductor? So, the 5 electrical conductors are silver, gold, copper, steel, and seawater. So those are conductors that electricity will go through easily. The insulators, these will not. Electricity won't go through rubber, glass, oil, diamond, or dry wood. Electricity will not be able to go through those. All right, so our first word is insulator. What is it?
Insulator.
And that does not let electricity go through. Some examples of the plastic water bottles, the garbage bags, wood. Conductor, what's the word?
Conductor.
That lets the electricity go through. A conductor is the leader, just like on a train. So we're going to add those to our vocabulary book in our notebook. So if you could just open up to the page. Just gonna get mine. Right here. Alright. So we're just waiting for it to come up. And we have one space, and we're gonna write one underneath, so. The first word we're going to write is conductor. So it's gonna come up. Conductor, and it will come up in 1 minute. It's just taking, okay, so I'll make it bigger. Conductor. Let's get that written on the last flap. And the definition of conductor is it lets electricity go through. So I'm gonna move my flap. The definition goes right underneath. Lets electricity go through. Can someone just give me an example that I can write underneath so I know what could go through? Ariel?
Gold.
Gold. Okay. I'll make it bigger. So quickly get that written down. So as you can see on our vocabulary page, in the square, we don't have any more spaces. So right underneath, we're going to write insulator. So just at the next, right here, just underneath the square. And it does not let electricity pass through. So an insulator does not let electricity go through. Does not let electricity go through. So get these two definitions down with our other definitions for electricity. Justice?
Today's my favorite day.
Okay, we're just gonna stay on science right now, we're gonna stay on track. All right. When you're done, put your pencils down, so I know that we're ready to move on. I still see some pencils up. Pencils down. All right. So, the next word, or the next thing we're going to do is we're going to complete this. Hold on. So our next assignment is going to come up on the board. You can close your science notebooks. And we're going to do an insulator and conductor sort. So at the top, I'm going to put the definition of conductor. And who can tell me what that definition is? Raise your hand and let me know. What can I write? Lupin? Okay, so I'm just a little note. Electricity goes through. And what about an insulator? What about an insulator? Ariel?
Electricity doesn't go through.
It doesn't go through. Electricity does not go through. And that's just a reminder to myself what the definitions are. Because if I look at this coat right here, is that a conductor or an insulator? So look at my definitions. What is it, honey?
Insulator.
It's an insulator. So I can look at my definition. Any questions about what we're doing? All right. So, Ariel,
We need glue and scissors.
I will pass those out. You will need glue and scissors. Justice?
Isn't it, yeah, and also something you can think about is, if it's an insulator, that means you can use it to block electricity.
You can use an insulator to block electricity, yes.
So you gotta think about what can stop electricity from touching you.
Very good, and then what will let it come through to you. Okay, and think about the things that let electricity go through. Water, aluminum, copper wire, a nail, a screw, chalk, a straw, marble. Plastic, do not let electricity go through. Just like the coat, will not let electricity go through. All right, and let me just see. All right. Okay, so, one more thing I want to talk about before I pass out the papers is I want to look at my chart. And I'm going to hold up an object and you're going to tell me if it's an insulator or a conductor. What is it?
Insulator.
It's an insulator. Can electricity go through this?
No.
No. How about my hand sanitizer?
Insulator.
What do you think?
Insulator.
An insulator or a conductor?
Conductor.
Conductor?
An insulator that will catch on fire. If it touch,
Because of the hand sanitizer inside?
Yes.
What do you think? Tell me why, Ariel. What did you say, conductor?
No, I said insulator.
Why do you think it's an insulator?
I think it's an insulator because it can count the bottle in it. Plastic, or glass, how it is. I think it's glass, so, I would think it says,
So it's an insulator because this is plastic, right? And you're saying it's an insulator because it can't go through plastic, right? Right. So it's an insulator because my bottle is plastic. And one more. My stapler. An insulator or conductor.
Both, because it has metal on it and it's plastic.
we know.
So, well, one person at a time. Okay, it has plastic on the top. Ariel?
Metal, is a conductor, so I'm gonna say it's a conductor.
It's a conductor. Okay. And, so we will start our sort. I need to